Welcome to InstaLearn AI. Let's start our Microsoft Machine Learning Operations Engineer Associate AI-300 exam-style Q&A series. Here's question 1. Question 1. You manage an Azure Machine Learning workspace, and you develop a machine learning model. You must deploy the model using a low-priority VM to take advantage of a pricing discount. Which deployment target should you choose? A. Azure Container Instances, or ACI. B. Azure Machine Learning Compute Clusters. C. Local deployment. D. Azure Kubernetes Service, or AKS. Think before you answer. The correct answer is B. Azure Machine Learning Compute Clusters. Here's why. Only Azure Machine Learning Compute Clusters support low-priority VMs, also known as spot VMs. These VMs offer significantly reduced pricing because Azure can reclaim them when capacity is needed elsewhere. Question 2. You create a binary classification model. You use the FairLearn package to assess model fairness. You must eliminate the need to retrain the model. You need to implement the FairLearn package. A. FairLearn. Reductions. Exponentiated gradient. B. FairLearn. Pre-processing. Correlation remover. C. FairLearn. Reductions. Grid search. D. FairLearn. Post-processing. Threshold optimizer. The correct answer is D. FairLearn. Post-processing. Threshold optimizer. Here's why. Exponentiated gradient and grid search are FairLearn reduction methods that require retraining the model with fairness constraints. Correlation remover is a pre-processing technique that modifies features before training. Since the data changes, the model must be retrained. Threshold optimizer, on the other hand, is a post-processing algorithm. It works by adjusting the decision thresholds on the predictions of an already trained model to improve fairness across different groups. Because it operates on the model's outputs rather than the training process itself, there is no need to retrain the model. That's exactly what the question requires. Final answer is D. FairLearn. Post-processing. Threshold optimizer. Question 3. A retrieval augmented generation (RAG) solution returns incomplete answers because relevant content is inconsistently retrieved from the knowledge source. You need to improve RAG accuracy without changing the embedding model currently in use. You need to achieve this goal while minimizing operational costs. Which two actions should you perform? Each correct answer presents part of the solution. Note: each correct selection is worth 1 point. A. Tune chunk size and overlap to match content structure. B. Implement an optimized re-ranker. C. Increase token limits for all requests. D. Optimize embedding vector length. Correct answers are A. Tune chunk size and overlap to match content structure. B. Implement an optimized re-ranker. Here's why. Adjusting chunk size and overlap ensures that context is preserved during retrieval, improving recall. Adding a re-ranker refines retrieved results by scoring relevance, boosting accuracy. Increasing token limits, C. Raises costs without fixing retrieval quality. Optimizing embedding vector length, D. Requires changing the embedding model, which is not allowed. Question 4. You need to recommend an experiment tracking strategy that ensures consistent experiment results. What should you recommend? A. Azure Machine Learning Job Output Logs. B. ML Flow Experiment Tracking. C. Application Insights Logs. D. Azure Monitor Alerts. Correct answer is B. ML Flow Experiment Tracking. Here's why. ML Flow Experiment Tracking provides a structured way to log parameters, metrics, artifacts, and results, ensuring reproducibility and consistency. Job Output Logs, Application Insights, and Azure Monitor Alerts are useful for monitoring and diagnostics but do not guarantee consistent experiment tracking. Question 5. A data science team completes multiple training runs within an experiment by using ML Flow. The team wants to store a selected model in Azure Machine Learning so that it can be versioned and deployed later. The model must be versioned centrally for reuse across environments. You need to version the trained model. Which two actions should you perform? Each correct answer presents part of the solution. Note: each correct selection is worth 1 point. A. Locate and capture the model artifacts from the outputs of the training run. B. Register the model in the Azure Machine Learning workspace. C. Tag the training experiment with a name. D. Export the model files to local storage. Correct answer are A. Locate and capture the model artifacts from the outputs of the training run. B. Register the model in the Azure Machine Learning Workspace. Here's why. First, identify and capture the model artifacts generated during the ML Flow training run. These artifacts contain the trained model files that need to be preserved. Next, register the model in the Azure Machine Learning Workspace. Model registration creates a centralized, versioned model asset that can be managed, reused, and deployed across different environments. Question 6. An organization validates generative AI applications during C/CD Microsoft Foundry. Evaluation must run automatically and block releases when quality thresholds are not met. Manual evaluation is no longer acceptable. Evaluation must use both predefined quality metrics and custom safety checks. You need to implement an automated evaluation workflow that supports both built-in and custom metrics. A. Enable application tracing to collect runtime telemetry. B. Review evaluation results manually after deployment. C. Monitor latency metrics during model inference. D. Implement an evaluation step by using GitHub Actions. Correct answer is D. Implement an evaluation step by using GitHub Actions. Here's why. GitHub Actions can integrate automated evaluation into the C/CD pipeline. This ensures predefined metrics and custom safety checks are run automatically. Releases are blocked if thresholds are not met, eliminating manual review. Other options, A, B, C, provide monitoring or manual validation but do not enforce automated blocking in C/CD. Question 7. You need to isolate training workloads while remaining cost-aware to address Fabricam Inc.'s issues, constraints, and technical requirements. What should you implement? A. Training jobs on a single shared compute cluster. B. Fixed-size compute cluster. C. Dedicated compute clusters per experiment. D. Managed compute targets with autoscaling. Correct answer is D. Managed compute targets with autoscaling. Here's why. Autoscaling managed compute targets isolate workloads while automatically scaling resources up or down, keeping costs under control. Shared or fixed clusters, A, B, risk resource contention and higher costs. Dedicated clusters per experiment, C, ensure isolation but are expensive and not cost-aware. Question 8. An organization is deploying several generative AI workloads by using Microsoft Foundry. Each workload must meet different requirements related to data governance, task specialization, and operational cost control. The organization requires models that meet the following requirements. Model behavior aligns with the task being performed. Data handling aligns with internal governance policies. Operational complexity and cost are justified by workload needs. You need to select the foundation model options that meet the requirements. A. A model optimized for conversational reasoning when deploying an interactive assistant. B. The largest available model to simplify operational management. C. The smallest available model to minimize the usage cost. D. A model that supports multiple input types when workloads require combined text and image analysis. E. A model that offers enterprise governance controls when workloads process regulated business data. Correct answers are A. A model optimized for conversational reasoning when deploying an interactive assistant. D. A model that supports multiple input types when workloads require combined text and image analysis. And E. A model that offers enterprise governance controls when workloads process regulated business data. Here's why. A. Choose a model optimized for the task, conversational assistant. Microsoft recommends selecting models based on workload fit, not size. D. If the workload requires text plus image analysis, choose a multimodal model that supports multiple input types. And E. For regulated business data, choose models and deployments that support enterprise governance and compliance controls. Question 9. A team develops and manages a conversational assistant by using Microsoft Foundry. The team must be able to validate that the assistant does not produce hateful responses before the application is exposed to any users. You need to evaluate the model output for hateful responses as part of a repeatable validation process. Which evaluator should you configure first? A. Protected material. B. Groundedness. C. Indirect attacks. D. Content safety. Correct answer is D. Content safety. Here's why. The requirement is to ensure the assistant does not produce hateful responses before release. In Microsoft Foundry, the Content Safety Evaluator is specifically designed to detect harmful content categories such as hate and fairness, violence, sexual content, self-harm. Therefore, it is the appropriate evaluator for validating hateful outputs. Question 10. An Azure machine learning workspace contains multiple registered versions of a model that is used in production. An older model version must no longer be deployable, but it must remain available for compliance review and potential rollback. You need to change the state of the model version to meet the requirements. What should you do? A. Archive the training dataset for the model version. B. Delete the model version. C. Archive the model version. D. Unregister the model version. Correct answer is C. Archive the model version. Here's why. Archive model version means keeps the model available for compliance and rollback, but prevents deployment. Delete or unregister means removes the model, making rollback impossible. Archiving the training dataset means does not affect deployability of the model itself. The right action is to archive the model version. Question 11. A team is deploying machine learning models to a production inference endpoint in Azure Machine Learning. The team requires a safe way to validate a new model version without disrupting existing users. You need to recommend a deployment strategy for controlled testing of a new model version. What should you configure? A. Traffic splitting between deployments. B. The model asset version in the registry. C. Deployment to a separate staging endpoint. D. An evaluation script in Azure Machine Learning. Correct answer is A. Traffic splitting between deployments. Here's why. Traffic splitting allows routing a percentage of live traffic to the new model version while the rest continues to use the stable version. This enables safe validation without disrupting existing users. Model asset versioning. B. Only tracks versions, not deployment strategy. Staging endpoint. C. Isolates testing but doesn't validate against real production traffic. Evaluation script. D. Helps testing but doesn't control deployment traffic. The best way to validate safely in production is traffic splitting between deployments. Question 12. Hotspot. Question. You are monitoring a fine-tuned large language model deployed in Microsoft Foundry. You evaluate the model before and after fine-tuning using the same evaluation dataset. You review the following evaluation results. Groundedness score baseline 0.82, fine-tuned 0.91. Relevance score baseline 0.85, fine-tuned 0.88. Hallucination rate baseline 0.06, fine-tuned 0.05. Response latency baseline 420 milliseconds, fine-tuned 430 milliseconds. You need to evaluate the following statements and select yes or no. Statement 1. The fine-tuned model shows improved grounding compared to the baseline model. Statement 2. The fine-tuned model introduced a regression in hallucination behavior. Statement 3. The fine-tuned model's response latency indicates a functional failure. Statement 4. The evaluation results indicate that fine-tuning improved overall response quality. Correct answers are as follows. Here's why. Statement 1. Yes. Groundedness improved from 0.82 to 0.91, indicating better grounding and responses. Statement 2. No. Hallucination rate decreased from 0.06 to 0.05, meaning hallucinations improved rather than regressed. Statement 3. No. Response latency increased slightly from 420 milliseconds to 430 milliseconds, which is not significant enough to indicate a functional failure. Statement 4. Yes. Overall metrics improved in groundedness, relevance, and hallucination rate, indicating better overall response quality despite a minor latency increase. Question 13. Drag drop. A team runs training jobs by using multiple Azure machine learning pipelines. The team must ensure that all runs use the same Python packages and system libraries. The solution must allow dependency updates to be versioned without modifying training code. You need to configure the workspace so that runtime dependencies are consistent and reusable. Which 4 actions should you perform in sequence? To answer, move the appropriate actions from the list of actions to the answer area and arrange them in the correct order. A. Store dependency versions in a configuration file. B. Define the required dependencies in an environment specification. C. Register the environment in the Azure Machine Learning Workspace. D. Reference the environment in training jobs and pipelines. E. Modify training scripts to install required packages at runtime. F. Create a new version of the environment when dependencies change. Correct answers are A, B, C, D. Here's why. The requirement is to ensure consistent and reusable runtime dependencies across Azure machine learning pipelines while allowing versioned updates without changing training code. The correct approach follows the standard Azure ML environment lifecycle. A. Store dependency versions in a configuration file. This captures exact package versions so environments can be reproduced and updated in a controlled way. B. Define the required dependencies in an environment specification. This is where you formally declare Python packages and system libraries using a Conda or Docker-based environment definition. C. Register the environment in the Azure Machine Learning Workspace. Registering creates a versioned, reusable environment asset that can be shared across pipelines and jobs. D. Reference the environment in training jobs and pipelines. This ensures all pipeline steps consistently use the same registered environment, guaranteeing reproducibility and consistency. Question 14. Drag drop. A company is standardizing generative AI development across multiple teams. Each team requires an isolated workspace. Governance and shared connections must be centrally managed. You need to implement a Microsoft Foundry environment structure that supports centralized governance and team isolation. Which configuration should you use for each requirement? You are given the following configuration options. A shared Microsoft Foundry project. A shared Microsoft Foundry resource. A Microsoft Foundry project per team. A Microsoft Foundry resource per team. Requirements to map. Isolated workspace for each team. Security and governance across teams. Correct answers are isolated workspace for each team, a Microsoft Foundry project per team. Here's why. A project provides the workspace boundary for development, so creating one per team ensures proper isolation while keeping work separated at the team level. Security and governance across teams, a shared Microsoft Foundry resource. Here's why. The resource acts as the central management layer where security policies, networking, and governance controls are applied consistently across all teams and projects. Question 15. A financial services company is deploying Microsoft Foundry to host generative AI workloads that process regulated customer data. The Microsoft Foundry environment must prevent any public network exposure while still allowing services managed by Microsoft Foundry to communicate with dependent Azure resources. Security auditors require that all traffic to and from the Microsoft Foundry resource remain on private networks, with no public endpoints available. You need to configure the Microsoft Foundry environment so that network access is restricted while maintaining full platform functionality. Which two actions should you perform? Each correct answer presents part of the solution. Note: each correct selection is worth 1 point. A. Configure a managed virtual network for the Microsoft Foundry resource. B. Use API key authentication for all model endpoints. C. Deploy the Microsoft Foundry resource in a separate Azure subscription. D. Disable public network access to the Microsoft Foundry resource. E. Disable all inbound network access. Correct answers are A. Configure a managed virtual network for the Microsoft Foundry resource. D. Disable public network access to the Microsoft Foundry resource. Here's why. Managed virtual network, A, ensures all communication between Foundry and dependent Azure services happens privately, without public exposure. Disable public network access, D, removes public endpoints, enforcing private-only traffic. Other options. B. API keys, controls authentication, not network exposure. C. Separate subscription, provides organizational isolation but doesn't enforce private networking. E. Disable all inbound access, too restrictive, it would block legitimate internal traffic needed for Foundry services. Question 16. A team develops multiple AI applications in Microsoft Foundry that rely on shared prompt templates. The team requires a centralized way to track, version, and reuse prompt content across projects. You need to recommend a solution to track and reuse prompt content. Which approach should you recommend? A. Store prompts as versioned files in a Git repository. B. Register prompts as datasets in the Azure Machine Learning Workspace. C. Embed prompts directly in application configuration files. D. Persist prompts in Azure Blob storage with folder-level organization. Correct answer is A. Store prompts as versioned files in a Git repository. Here's why. Git repository A. provides centralized tracking, version control, and reuse across multiple projects, exactly what the team needs. Datasets B. intended for training, evaluation data, not prompt templates. Configuration files C. embedding prompts here makes them hard to reuse and version across projects. Blob storage D. good for storage, but lacks built-in version control and collaboration features. The best practice is to store prompts as versioned files in Git, ensuring consistency, traceability, and reusability across Foundry projects. Question 17. A team plans to deploy a large foundation model in Microsoft Foundry as part of a new enterprise AI capability. Different business units across the team's organization will access the model from various internal applications. You need to deploy a foundation model by minimizing latency. Which deployment type should you use? A. Developer. B. Data Zone Batch. C. Data Zone Standard. D. Global Batch. Correct answer is C. Data Zone Standard. Here's why. Data Zone Standard, C. designed for low latency inference, making it the right choice when multiple business units need fast responses from a shared foundation model. Developer, A. intended for experimentation and testing, not optimized for production latency. Data Zone Batch, B. optimized for large-scale batch processing, not real-time low-latency workloads. Global Batch, D. similar to batch, focused on throughput rather than minimizing latency. For enterprise AI applications requiring fast, interactive responses, the correct deployment type is Data Zone Standard. Question 18. A company's platform engineers manage the resource settings and governance of Microsoft Foundry. Developers must be able to create and update project assets but must not be able to change resource-level configurations. You need to enforce least privilege access for the engineers and developers. Which two actions should you perform? Each correct answer presents part of the solution. Choose two. Note: each correct selection is worth 1 point. A. Assign a resource-level Azure AI Administrator role to the platform engineers. B. Disable Microsoft Entra ID authentication for the Microsoft Foundry resource. C. Assign the Azure AI Developer role to the developers. D. Share a single API key across all teams. Correct answers are A. Assign a resource-level Azure AI Administrator role to the platform engineers. C. Assign the Azure AI Developer role to the developers. Here's why. Azure AI Administrator, A. grants platform engineers the ability to manage resource-level settings and governance. Azure AI Developer, C. grants developers permissions to create and update project assets, without allowing them to alter resource-level configurations. B. Disable Entra ID authentication, would weaken security, not enforce least privilege. D. Share API key, violates least privilege and security best practices. The correct approach is to assign administrator role at the resource level to engineers and developer role to developers, ensuring least privilege access. Question 19. You have a Microsoft Foundry project. You plan to use the Microsoft Foundry portal to fine-tune a base Azure OpenAI service model that can accept both text and images as input. You need to choose the suitable model. Which model should you choose? A. DaVinci 002. B. GPT-4o. C. GPT-35 Turbo. D. GPT-4. Correct answer is B. GPT-4o. Here's why. GPT-4o supports multimodal inputs, text plus images, and is explicitly listed in Microsoft Foundry documentation as fine-tunable for vision tasks. It is optimized for enterprise workloads requiring multimodal capabilities. DaVinci 002, legacy text-only model, not multimodal. GPT-35 Turbo, text-only, lower latency but no image input support. GPT-4, advanced text model, but the standard variant does not support multimodal fine-tuning in Foundry. Question 20. Note: this question is part of a series of questions that present the same scenario. Each question in the series contains a unique solution that might meet the stated goals. Some question sets might have more than one correct solution, while others might not have a correct solution. After you answer a question in this section, you will not be able to return to it. As a result, these questions will not appear on the review screen. You work in Microsoft Foundry with a prompt flow. You must manually evaluate prompts and compare results across prompt variants. You need to capture the inputs, outputs, token usage, and latencies for each flow run for the evaluation. Solution: create prompt variants and compare their outputs in the evaluation experience. Does the solution meet the goal? A. Yes. B. No. Correct answer is A. Yes. Here's why. The evaluation experience in Microsoft Foundry prompt flow is designed to let you run prompt variants and capture inputs, outputs, token usage, and latencies. By creating prompt variants and comparing them in evaluation, you meet the requirement to manually evaluate and compare prompts with full run metrics. Question 21. Note: this question is part of a series of questions that present the same scenario. Each question in the series contains a unique solution that might meet the stated goals. Some question sets might have more than one correct solution, while others might not have a correct solution. After you answer a question in this section, you will not be able to return to it. As a result, these questions will not appear on the review screen. You work in Microsoft Foundry with a prompt flow. You must manually evaluate prompts and compare results across prompt variants. You need to capture the inputs, outputs, token usage, and latencies for each flow run for the evaluation. Solution: use the Prompt Flow SDK to enable tracing for the flow before executing runs. Then run the flow to generate traceable results. Does the solution meet the goal? A. Yes. B. No. Correct answer is A. Yes. Here's why. The Prompt Flow SDK tracing feature allows you to capture detailed run metrics such as inputs, outputs, token usage, and latencies. By enabling tracing before executing runs, you generate traceable results that can be reviewed and compared across prompt variants. This matches the requirement for manual evaluation with full run metrics. Question 22. Note: this question is part of a series of questions that present the same scenario. Each question in the series contains a unique solution that might meet the stated goals. Some question sets might have more than one correct solution, while others might not have a correct solution. After you answer a question in this section, you will not be able to return to it. As a result, these questions will not appear on the review screen. You manage an Azure Machine Learning workspace. The Python script named script.py reads an argument named training_data. The training_data argument specifies the path to the training data in a file named dataset1.csv. You plan to run the script.py Python script as a command job that trains a machine learning model. You need to provide the command to pass the path for the dataset as a parameter value when you submit the script as a training job. Solution: Python train.py training_data. Does the solution meet the goal? A. Yes. B. No. Correct answer is B. Number. The solution provided, Python train.py training_data, does not meet the goal. The correct approach in Azure Machine Learning is to run the actual script, script.py, and pass the dataset path argument properly, not just the literal string training_data. Question 23. Note: this question is part of a series of questions that present the same scenario. Each question in the series contains a unique solution that might meet the stated goals. Some question sets might have more than one correct solution, while others might not have a correct solution. After you answer a question in this section, you will not be able to return to it. As a result, these questions will not appear on the review screen. You work in Microsoft Foundry with a prompt flow. You must manually evaluate prompts and compare results across prompt variants. You need to capture the inputs, outputs, token usage, and latencies for each flow run for the evaluation. Solution: in Microsoft Foundry, turn on tracing for the prompt flow of the project and execute test runs to produce trace data. Does the solution meet the goal? A. Yes. B. No. Correct answer is A. Yes. Enabling tracing in Foundry does indeed capture inputs, outputs, token usage, and latencies, so the solution correctly meets the goal. If you found this video helpful, don't forget to like, share, and subscribe to InstaLearn AI for more exam-style questions, explanations, and certification tips. Thanks for watching, and I'll see you in the next video.